beginners algebra students, Mr. Lawrence here, and we're just going to do a quick summary factoring followed by a couple quick problems for you to try. So remember, the first type of factoring we always try is GCF. We always look for the greatest common factor, okay? Sometimes it doesn't really show up until later in the problem as you have discovered on some of them, but most of the time it can show up right away. Then we have to check how many terms there are, right? Check how many terms, okay? If there's two terms, then there's only one possibility after we've GCF'd, and that is the difference of perfect squares, okay? So we have to have a perfect square minus a perfect square or some form thereof. If there's two terms and there is no subtraction, well then the rest of the problem is prime. It might not totally be prime because we might have factored out a GCF. If there are three terms, well then we can check first of all to see, is it a perfect square trinomial? That will save us a lot of trouble, because if it is a perfect square trinomial, it'll factor really simply. That's where the first and third terms are both perfect squares, and the middle term is twice the product of the square roots of the first and third terms. If it's not a perfect square trinomial, we can check if a equals 1, and if a equals 1, we just list the factors of c, and then we either have to add or subtract those factors to get the middle term, right? Now, if a does not equal 1, it's similar, but it's more complex because we have to list the factors of a and the factors of c. We have to multiply them together and then combine them in such a way to get b, right? And then obviously there's the four-term one, which we just learned yesterday. When there's four terms, that's when we use grouping. And grouping is nothing more than GCFing 3 times. I guess it could even be more. There was an example yesterday where I did it 4 times, I think. Okay, so I've got 4 problems here. If you would like to just go ahead and try them on your own, that would be awesome. And then pause the video, and when you're done, unpause the video, and I'll show you how I would do them. All right, well, the first thing I'm going to do on this first one, please, if you haven't tried them, go ahead and do it. I'm going to factor out a GCF. It's really strange, kind of a strange problem here. Well, I think 6 is going to be the GCF of 12 and 18, and then a is going to be the GCF of a squared and a. And so when I pull out a 6a, I'll be left with a 2a, and then a positive 3y squared. And so that's just a straight GCF problem. There's nothing else I can do with this inside. It's not the difference of perfect squares. It's not a trinomial. It's done, okay? Number 2, looks like my GCF might be 3, so I'm going to factor out a 3. I'll have y squared minus 49, right? If you're wondering how I did that, so if it's 3 times 50 is 150, 147 would be 3 less. It would be 3 less, so I'd only have 49. Now in here, inside this quantity, I have the difference of perfect squares. So I have to do y plus 7 in a quantity and y minus 7. And again, notice that I did not throw that GCF away. I factor it out, but it's not gone. All right, number 3, Mr. Lawrence, the first thing I'm going to do is I'm going to multiply everything through by 10. And that's going to turn this into 4r squared plus 16r plus 16. Now, I see a GCF of 4. I'm going to factor it out. Okay, and that's going to leave me with r squared plus 4r plus 4. And I'm thinking that's a perfect square trinomial. I think it is because the square root of this is r, and the square root of this is 2, and 2 times r doubled is 4r. So this is going to factor as 4 times r plus 2 squared. Or alternatively, you could have had this, and it would be considered the same thing. Okay? Now some of you are saying, well, I didn't notice it was a perfect square trinomial, so I just listed the factors 4 and did it that way. Well, that's fine. You get the right answer. That's not a problem. Okay. This one here is a grouping problem. How do I know? There's 4 terms. So I'm going to group these two together. Going to make sure I grab the sign on the second pair there. Put a plus sign in. Looks like my GCF is going to be a 4a squared. Just had a little light bulb go off in my head. I'm thinking of something. I don't know if it's going to come to b, but let's wait and see about that 4a squared. Okay, I'm going to have a 5x minus a y. And then here I'm going to factor out a -9, I think. Yeah, I see something happening. Do you see it? Okay, and that's going to leave me with a, I didn't get the whole GCF there. Sorry, I got the GCF of the coefficients, but it looks like there's a b squared that's common to both terms. So I'm going to factor out a 9b squared. Okay, and that'll leave me with a 5x minus y. Yeah, there we go. And then when I factor out the 5x minus y as the next greatest common factor, I'm going to be left with a 4a squared minus 9b squared. And yep, I was right. I'm left with the difference of perfect squares. That's what I was thinking when I got a perfect square here and minus a perfect square there. I was pretty sure I was going to get the difference of perfect squares. So I'm going to have the quantity of 5x minus y times the quantity of 2a plus 3b times the quantity of 2a minus 3b. And that's it. Homework is, I don't know if it's 8 problems or 10 problems, but it's just different types of factoring where they don't tell you what type to use. That's it, guys. I'm very proud of you. You're working very hard, and I honestly don't know if we'll be back this year or not till September. I mean, it makes me sad that I don't get to spend another quarter with you, ladies and gentlemen. I mean, I really love our class. It's been a special year. Thank you for everything. But at least we can communicate this way. All right. That's it for the video. Mr. Lawrence signing off. Have a good night, everybody.